Good evening, everyone. You are welcome to today's lesson. In our last lesson, we brought in an architectural design. Then we were able to identify the points of our columns. Today, we are going to be doing the general floor arrangement of that particular design. So, in every design, you must look at the architectural design, then identify the points you have to put your columns. Then after that, you now arrange your floor, to state the type of panel you have, how many panels you have, then you number the beams. So it is with this you can start your design. So in today's lesson, I came up with the structural draft of the architectural design. This was the design brought to us by the architect. In the architectural design, the dimension from wall to wall, that's the clear span between wall to wall. But in this structural design, we are dimensioning from center to center. We actually dimension this building from center to center, so that when we are designing, we will now use these dimensions to do our design. And again, is every structural design that you take to site to set out the building. Today, what the architect did here, this dimension he put here was 4.2 meters. Here, from center to center, center to center now, the size of the beam was size of the walls was 225, the one they call 9 inches. So 225, half of 225 plus half of 225 is equals to 225. So it means every dimension we are having here is we are going to be adding 225. So from the architectural design, which is, you can look at it, you can glass through up there, it's a display on the screen. The architectural design, we have 4.2 here. So because we are doing center to center, it means you'll be adding 225. From the architectural design, we have 4.2. Here we are now having 4.25. The architectural design, we have 3.6. By the time you add 225, we have 3.825. Here in the architectural design, we have 3 meters. By the time you add 225, we have 3.225. That is how we were able to get all this. Now, remember that in the architectural design, we told you that to break this span, we had to introduce a column here and here. So that made this dimension to be 4112.5, 4112.5, because you are dividing 8225 by 2. Now, we want to start identifying we want to start labeling the panels to know the type of panel we have here. You recall that in our school days, they will tell you that Ly over Lx, when it's less than 2, this one becomes two-way slab. Then when Ly over Lx is greater or equal to 2, it becomes one-way slab. Now, what we want to do here now, but it's not in all cases that you adopt this. Me, if I'm doing mine, last span I follow this, but smaller span I don't follow when the span is not long enough. For instance, you have a column here, then if I want to make this beam similar to this beam, I can introduce this beam, dotted line beam. Then same goes 1, 2, so this is a beam that we're introducing here now. It means this span is a panel, this span is a panel, the whole of this is a panel, the whole of this is a panel, then we have another panel, we have another panel. Now let's start by placing our panels in the slab. Now from what we have discussed so far, we have a calculator here now. This panel, the longer side, Ly means the longest span, Ls means the shorter span. So from this panel we have 4425, then we have 4112.5. It means that this 4425 is shorter, is longer than 41125. So when you want to get the type of panel, you divide 4425 divide by 4112.5. Sorry, 2.5. This one will give me 1.08 approximately. So it means that this one is a two-way slab. It's less than 2. It's a two-way slab. Two-way slab is represented like this. It's represented like this on your panel. This is your, sorry, don't mind my diagram. It's two-way slab. That's panel 1. Panel 1. This two-way slab. Now let's go to this. This panel and this panel, they are similar. So it's two-way slab. Two-way slab. It's panel 2. Then we have this other panel. The Ly is 4425. The Lx is 2025. So when you divide, go to the calculator. 4425 divided by 2025. Right? Now this one is greater than 2. This one is greater than 2. And when you have a Ly over Ls greater or equal to 2, means it's one-way slab. So, and this one way should be represented like this. One-way slab. Call this one panel 3. The reason why it's represented like this, we are telling you that the main bars are going to run along the shorter span. The main bars will run across the shorter span. Then we have this panel here. We have the panel is 3825, and then the longest span is 7025. 3825. So we have to do our calculations. 7025 divided by 3825. This one we have 1.8. 1.8 is less than 2. It's a two-way slab. You can also represent this one here like this. Call this one panel 4. Then this is a slab I'm talking about now. This one we have a span of 1.725, then we now have a span of 3225. So without much calculation, this one is a small span. But if you divide, you discover that it's less than 2 meters. So I cannot call this one a two-way slab. This slab is a one-way slab. Call it, reinforce it like that, and call this one panel 5. But if you want to make it a two-way slab, fine. But for me, I will leave it as a one-way slab. Remember, this is a stair hall. There's nothing here. The staircase is the staircase is designed separately, so there's nothing here. So we are now moving to this panel. We have 7 meters here. Now have 3225. So let us know the type of panel we have here. 7025 divided by 3225. What we are having here is 2.18 approximately. So it means that since Ly over Ls is greater than 2, then we call this panel one-way panel, and we call this panel 6. You can see this is the shutter span. Every panel that is one way is represented like this along the shutter span, and this one is telling you that after the calculations, your reinforcement, the main bar, is going to, run through the shutter span. So that is that for the paneling. Then for the beams, okay, we continue with that in our next class for the beams because time is fast spent. Okay, let's start doing something for the beams. You can call this one beam 1. This is a continuous beam. This beam 1 is a continuous beam here. Then let us use the horizontal beams, for instance, to start labeling. Remember that this is a beam now. So we also call this one beam 2. Then the next horizontal beam is this beam. Alright, we call this one beam 3. Then the next horizontal beam, this is a stair hole, is this one. Okay, this beam and this beam, they are the same. I can call it, okay, let me call it beam 4, sorry. I can call this one beam 4. Then the next horizontal beam is this one. I call this one beam 5. Alright, beam 5. Beam 5 runs from here to here. Now let's go to the horizontal vertical beams. We have gotten beam 5. Then here we call this one beam 6. Then the next vertical beam, we call this one beam 7. Then we call the next vertical one, we call this one beam 8. Then the last one, we call this one beam 9. So in this class, we have been able to arrange the floor. This is general floor arrangement. We have panel 1, we have panel 2, we have panel 3, panel 4, panel 5, panel 6. Then we now move to beams. We started by naming the beams according to like horizontal beams. This is beam 1, this is beam 2, this is beam 3, beam 4, then beam 5. Then vertical beams now, call this one beam 6, beam 7, beam 8, and beam 9. Thank you very much. Please, what I want you to do for me now is to share this page, follow, and be ready for the next class. Thank you and God bless you. In the next class, we are going to be talking about loadings. But please, before the next class, this particular design is ground floor, which we are still going to use for the first floor and the roof level. So since they are the same, this is the slab arrangement. So after the calculations, we will now tell you how everything is done. Thank you and God bless you.